Yeah. So how do we set up an absolute value less than problem? On Thursday, this is the one where it gets set up between the two. Like that. And then to solve for x, we want to get x by itself in here. So x is between 1 and 5. So this is going to look a lot like number 9. What does the line x equals 1 look like? Actually, maybe put it over here. Yeah, x equals 1 is a vertical line at 1. Since it's x is greater than 1 and not equal to, I'm going to make it dashed. And x equals 5, of course, would be over here at 5. Dashed. Okay, so this is saying x is greater than 1 and less than 5. So it's all the values in between 1 and 5. All the x values between 1 and 5.
So why is it equal?
Hmm?
Why is it equal?
Why did I graph x equals 5? Okay, well, I didn't really graph x equals 5, but if I was going to graph x equals 5, it would have been this solid line right here. But that's just the line it approaches. It doesn't actually get there.
Wait, so the dash is the not equal to.
Right, so these are both dashed.
And then equals to is a solid line.
Right. It's a solid line because the points on that line are part of the solution. If it's a dashed line, they're not part of the solution. All right, 15. Oh, 14. Yeah, I always forget about this problem. I'm repressing my memories. 2 less than x plus. I'm going to do it a little bit fast, so sorry about that. It's kind of a pain in my hide. So, you guys see what the problem is on this one? It's between two numbers and its absolute value, both. So, this is kind of saying two things. It's saying x plus 4 is greater than 2, and it's saying x plus 4 is less than 3. And you kind of solve both of these separately. So to set up a greater than, gosh, it's an or. You guys remember that? You do need to know this part. Absolute value greater than sets up as an or. This is from Thursday also. And last year, and algebra 1. And if it's a less than, is like the last problem, it sets up between. So -3 less than x plus 4. And then you solve all these things.
What's going on?
I solved all those things.
Mr. Jordan, on the first one, is it dash or solid?
Are you talking about this one?
No, like the first question. Cause,
Number 1?
yeah, but it says like.
Did I copy it wrong?
No, number 1, like
Oh.
B number 1.
Oh, I don't have that up here. What is number 1 would be solid. I did number 1 yesterday.
I know, but
Did I put dashed? Probably not.
no, it was solid. It's number 2. But then the third one is dash, right?
Yes.
But why is the first one solid?
It's equal to.
It's greater than or equal to.
It's the
clicking on the top part, like the class exercises part.
You're on the wrong page.
Oh. Huh. Oh.
There it is.
This is raining.
Alright, where was I? Gosh, does it get harder? Oh, there's no answers in this stinking book. Ah.
You should just make us stop at 14.
Yeah, we'll skip 14. This is by far the hardest. You would have to do less than -6 and bigger than 7 and good grief.
Isn't that between them?
So it'd basically have to be between -6 and -7 and between -2 and -1.
That's not bad. That's not
Yeah, but explaining why it's that is very hard, very difficult. It's because of the and the ors and how they work together. And my book doesn't even have an answer sheet for this thing.
You really got my hopes up with saying yeah when I first said, can we just stop at 14? I was like,
We can not do 14. That's y is greater than x cubed minus 9x. That problem disappoints me every year. All right. What do you guys think on this one? Any ideas? Well, it's not quite a square. Yeah, after you take an x out, it's a square minus a square. Yeah, you should probably notice it's factorable. Oh boy. And yes, x minus 3, x plus 3. So what are the roots? What are the zeros of this function?
0, 3, and then -3.
0, 3, -3. So this is one of those where we kind of did a rough sketch. What shape will it take?
Like a up, down.
Okay, I called it the squiggle. That's the official title. Because it's an x cubed, it's going to be a squiggle. Is it going to be solid or dashed?
Dash.
And a normal positive x cubed will start low and end high. And where are we shading?
Boob.
What?
Boob.
I thought you said boop. Boop. What the boop? Best shading ever.
do you like Rhea?
Like what?
Rhea?
A movie? Or the city in Brazil? Yeah. Rio de Janeiro. I don't think I've seen the movie.
You have to.
What?
It's so
It's-
good.
does it have parrots in it or something?
Yeah, and Anne Hathaway plays.
I think I've seen like 10 minutes of it.
Or Anne Hathaway.
Oh,
The yellow bird is
Okay.
a moose. I love the yellow bird.
12? Are you 12? Should be you.
Okay. You didn't have to say that.
Okay. So on this next section, it's combined inequalities. So there's going to be a couple different graphs on the same graph. All right. So the second one, I'm going to change the slope-intercept form to be graphed. So I'm going to get y by itself. tomorrow. Well, I didn't say difficult, I said it kind of ties whatever we did right before this, which might be difficult, I guess.
Is it gonna be today
Yeah.
or tomorrow's is?
All right, now, what does x equals 0 look like? Or maybe I should ask, what's x equal 1 look like? Just as an example. X equals 1 is a vertical line through 1 on the x-axis. So x equals 0 is a vertical line through 0 on the x-axis. So basically, it's the y-axis. This is in slope-intercept form. It's a linear inequality, so it's going to start up 2. And where are we going to go from there? Down 1, right 2. Okay, is that line solid or dashed? It's solid as well. Okay, when you draw 2 lines, notice it creates 4 regions, kind of 1, 2, 3, 4 here. One of those regions contains the solution set of answers. Okay, so on my first line, it was x is greater than or equal to 0. So this vertical line. Where are the x values greater than or equal to 0? To the right or the left? To the right. So that would be either region 1 or region 2. Okay, for the other line with the slope, it's y is less than, so it's below. So that'd be region 1 or 4. So what region do they have in common? 1. So we gotta shade that. Region.
I feel like we've done this like last year.
Yes, we've done it last year. Did we do it in Algebra 1? Maybe just one line in Algebra 1, maybe not.
I remember like something like this in the final.
Was it? Did you get it right?
Probably. I don't know. I was smarter back then than I am now.
Brains leaked out over the summer. Alright, dos mas. X is less than 0. X minus 2. Okay, that's kind of the same thing as what we just did. Okay, on this one, so what does x equals 0 look like again? We just did it.
The 0 line.
It's a vertical line through the middle, so it's like the y-axis. This one would be dotted, however. It's kind of hard to show that, especially when you're only using like one color. But whatever, it's a mess. Alright, this other line is in standard form, so let's get y by itself. So we can graph it. Okay, remember when you divide by a negative, the inequality, or multiply by a negative, the inequality switches. Okay, so that one's going to start up 3, and it's going to go rise 3, run 2. So rise 3, run 2, or go backwards, down 3, back 2. That line is solid. Oh boy. Alright, so we got 4 regions here. Now the first line, it was x is less than 0. So which direction is x less than 0? Left. That's the only line where there is no up and above and below. There's just a left and a right. So negative x values are this way. So that's either region 3 or 4. And then on my second line, after I divide by negative, it became a greater than. So where is it greater than this line?
4.
1 and 4. So 4 is what they have in common.
I'm surprised. Like, she's like LGBTQ. Like, LGBTQ people.
She's canceling her shows like right before.
Yeah.
Like, don't let me do your job.
Bonus very special thing. I got a Christmas song in my head.
Endorsing anyone.
Thank you.
Oh, Shelby Goodson. I need everyone to take a look at Shelby's shading.
That is crazy.
Everybody bear witness.
Why is it different every
It's
time?
like you're holding up
Your number
Simba.
7 is like on track.
Like, I don't know how you can find 10 different ways of shading.
Like you like go like every single direction but the right direction.
This is so good, Shelby. That means
We'll hang it up on the wall next to the kindergartner's self-portrait.
No different.
By the way, you guys should look at the kindergartner's self-portraits on the wall because
Zane's is so
Zane.
funny.
You literally showed me.
Zane's is black and Adeline's is brown.
Yeah, it's like his is like just the ring around his face is black, like really black. Or maybe it was a different one.
well, the face was pre-drawn. They had
Yeah.
to
And
like
it's just
draw it in.
dark, and he's like not that dark.
He had like jagged teeth.
Yeah.
The way he shaded around his eyes made him look like a monster.
I remember when I did mine, I couldn't find like skin color, so I was just like I did color misting.
Mr. Jordan found the thing so funny that he saw me walking in the hallway, had to stop me and was like, "Come here," and then showed me himself.
I saw it yesterday and I was telling it.
I showed it a couple other people too.
Yeah, but it's like,
And it's right next to like the girl who made herself like really cute and sweet. And then there's Zane.
And this is like the first one in the row.
I remember Gianni used to gloat about hers in practice the other day, and he was like, you know those like bouncy balls you like hold on to and you like sit on them and bounce around? Well, he got on top of the bleachers and jumped off of it and landed on his butt. Like, did not land on the ball at all. He got up, he said, well, I didn't break a bone. And he just kept going.
Surprisingly.
So funny.
Who is this?
Zane.
The kindergartner?
Yes.
He jumped off the bleachers.
Like off the top bleachers, like they were pushed in all the way.
Right,
He
right.
jumped off the top.
Dang, I'm surprised he didn't break something.
Yeah. He just got up and kept going.
He's a wild child. Okay, maybe there's something to that portrait. So we've got a, what's x squared minus 2 gonna look like?
Such a good question.
Parabola. Y equals x squared is our parabolas. So how do we graph parabolas normally?
Plug it in.
Negative b over 2a, right? The b value, there is no x value, so the b value is like 0. So that means the vertex is going to be at 0. Actually, it's going to be at 0, negative 2, because that's what this minus 2 does. It just moves the graph down 2. And if we plug in 1 and 2, we get those numbers. Anyway, that's
But not real.
how we graph it.
So Notebook just came out with the Notebook again. It's the Ryan Gosling and Emma Stone.
I thought that was La La Land.
La La Land's already. Wait.
No,
La La Land.
You idiot.
No
the
wait.
Notebook has
The Notebook is Ryan Gosling and someone.
some other girl.
Her name in the movie is Allie. I don't know what it is. It's my favorite.
Anyways,
Hey, I got one right.
okay,
I was like Emma Stone. I was thinking.
how are we graphing y is less than x? Shh, shh, shh. How about this? Hush.
If
This-
anything below the next line, like that.
Okay, this is basically slope, when you have a y-and-x, it's slope-intercept form. So the slope is 1 and the y-intercept is 0. So you start at 0, go up 1 and over 1. And this line is dashed. Now, are there still 4 regions? 1, 2, 3, 4. Yeah, there are 4 regions. Oh. Well, these two would kind of be the same regions. It's kind of complicated. All right, anyways, let's figure out where we're shading. So on the parabola, it's y is greater than. So that means it's in the bowl. So it's either like region 1 or region 2 here. Okay, and then on the line, it's y is less than. So it's got to be below this line. So it's region 1.
That's like the same with 22, but it's like the opposite, like way of the parabola.
Oh, you already did
You're
22.
so confident.
Yeah.
saying.
Unless I did 22 wrong, but
You know, it's
it
fine.
The
looks like,
parabola is upside down on 20.
yeah, it's like the opposite. But also like the line's like, it's like weird. It's like not one to one.
But I mean, it's